Powers and exponents. What is a power? A product of repeated factors can be expressed as a power. Remember, a product is a multiplication problem. Repeated means that we're going to be multiplying the same thing over and over and over again. So a power is going to consist of a base and an exponent. The exponent tells you how many times the base is used as a factor. So parts of a power, we have the base and we have an exponent. The base is going to be just written like you would normally write a number, and then the exponent is going to be a smaller number set in the upper right-hand corner. So if you look at these examples, we have 3 to the 6th power is how you would read it. 3 would be considered the base. The exponent would be 6, which means we're multiplying 6 3's together. So written out as a product of repeated factors, 3 to the 6th is the same as 3 times 3 times 3 times 3 times 3 times 3. The next example, we have 5 to the 2nd power. The 2nd power is read as squared. So this is 5 to the 2nd power, or 5 squared. The base is 5. The exponent is 2. And written as repeated multiplication, 5 squared would be 5 times 5. And finally, we have the base of 14 and the exponent of 3. This could be read 14 to the 3rd power, but an exponent of 3 has a special name, cubed. So this could be 14 cubed, which means 14 times 14 times 14. Now we're going to try to work the opposite way, and we're given repeated multiplication that they want us to write using exponents. So if you look first, we have 8 times 8 times 8 times 8. The repeated factor here is 8. And we're multiplying 4 8's together, so written using exponent would be 8 to the 4th power. Next we have a times a times a times a times a times a. Our repeated factor would be a, and we're multiplying 6 a's together, so this would be a to the 6th power. And if you look at this final example, we have 9 times 9 times 5 times 5 times 9 times 5 times 5. Well, notice here I have 2 different factors, 9 and 5, so I'm going to have 2 different bases, 9 and 5. There's 3 9's that are being multiplied together, so that would be 9 to the 3rd. And then there's 4 5's being multiplied together, so that would be 5 to the 4th. So written using exponents, I would have 9 to the 3rd times 5 to the 4th. These next examples ask me to evaluate. Evaluate means that we're actually going to go ahead and we're going to multiply these powers out. So 2 to the 4th power means 2 times 2 times 2 times 2. The easiest way to multiply several numbers together is by chunking them. So I can multiply 2 numbers at a time. So I'm going to chunk the first 2 times 2 and then the next 2 times 2. Well, 2 times 2 is 4, So I have 4 times 4, which is 16. Next I have negative 3 in parentheses to the 5th power. The parentheses are important here. Anytime the negative is included inside of parentheses and it's being set to a power, that means that I repeat the negative with the number. So negative 3 in parentheses to the 5th power means negative 3 times negative 3 times negative 3 times negative 3 times negative 3. If the negative 3 was not in parentheses, I would bring down 1 negative sign and then just 5 3's. Because the negative is in parentheses, I repeat. If the negative was not in parentheses, I would bring down 1 and only repeat the number. Again, I'm going to chunk these numbers together. So I'm going to chunk the first negative 3 times negative 3 and the next negative 3 times negative 3. Negative 3 times negative 3 is 9, so I'm going to be left with 9 times 9 times negative 3. Go ahead and chunk 9 times 9 is 81, and 81 times negative 3 is negative 243. The final example is 3/4 cubed. That means I need to multiply 3/4 times 3/4 times 3/4. If you remember multiplying fractions, we multiply straight across my numerators together and then multiply straight across the denominators together. So we have 3 times 3, which is 9, times 3, which is 27. And similarly, I'm going to multiply my denominators. 4 times 4 is 16, and 16 times 4 is 64. So 3/4 cubed is 27 over 64. The final examples asks us to evaluate if A equals 5 and B equals negative 4. What we have to do is we have to substitute 5 for A and negative 4 for B. It's very important that when you substitute into an expression, you make sure that you put whatever you're substituting in parentheses. So if you look at the first one that we need to evaluate, we have A squared plus B squared. Well, I'm going to substitute 5 for A and negative 4 for B, and I'm going to say 5 squared plus, in parentheses, negative 4 squared. Well, 5 squared is 25, and negative 4 squared, in parentheses, is negative 4 times negative 4, which is a positive 16, and 25 plus 16 is 41. Next, again, I'm going to substitute. This time, inside of parentheses, I have A plus B, and close the parentheses, and then it's squared. So I'm going to substitute 5 for A and negative 4 for B. Using the order of operations, I would need to go ahead and do the operations inside of my parentheses first. A 5 plus negative 4 is 1. So I would have 1 squared, which means 1 times 1, which is just 1. In the last example, go ahead and plug them in again. This time I have A plus B squared. This time I do not have parentheses, so I need to go ahead and do negative 4 squared, which is negative 4 times negative 4, which is a positive 16. 5 plus 16 is 21.